So here we are discussing two apparatus being used in electronics and communication engineering. The first apparatus is called the function generator, which is used to generate signals. This apparatus is called the CRO, cathode ray oscilloscope, which is an eye of an electronic engineer. It is used for viewing the signal. We can see here, right now you can see this panel. In this panel, what is written? Frequency, that is 1000 Hertz. What kind of signal is this? SIN. SIN means a sinusoidal. Then what is the amplitude? This thing denotes the amplitude of the signal, means 2.00 volt. Now if you want to change this frequency, if you want to change the frequency, and can change using this. So it is becoming less, it is becoming more, whatever you like. Right now I set this frequency to 1000 Hertz. Now change it. Next, if I want to change the amplitude, so write the amplitude is 2 volt. If I want to change the same knob, changing the amplitude, various amplitude, whatever you want. So right now the unit is in volts. If you want to make this unit in millivolts, see, you have to divide by 10, multiply by 10. So this two, either divide this by 10 and multiply it by 10. If I divide it by 10, now you can see your unit became millivolts. Now let us come back to volts when I press this into 10. When I press this into 10 one more time, you see the point from here move to one more into 10. So right now let to be the same amplitude 2 volt and having the frequency 1000 Hertz. Now what is the function? My function is sinusoidal. You can change the function from sinusoidal to various functions like triangular. If you press it again, square. If you press it again, this is again a square. Ramp, it's 2 volt. Again 1. Ramp minus 2 volt means a negative ramp. This is pulse 1 volt, because when we say pulse, it denotes only from reference to upper level or reference to below level. When I press it again, it says a pulse for minus 1 volt, means below. Then a DC voltage, then again back to the sinusoid. So right now we have set it for a frequency of 1000 Hertz, for an amplitude of 2 volts and a function of sinusoidal wave. Now when I connect this from this written as output, you might have seen here written as, I will just open it for your convenience. It's written output, means whatever is generated from this, will come out from this output. I connect here and will go through this wire. So important buttons in this function generator are this frequency, amplitude functions, and to vary this, whether frequency or amplitude, use this knob. Well, to multiply that amplitude of frequency into 10 or divide it by 10, you can use this too. So now this signal, what has been generated from the function generator, is coming through this CRO cable, which have a two-side PNC connector. One connector I connect to here, and the other connector I am connecting to the CRO. Now coming to CRO. CRO is the eye. It has two channels, means it can view two different signals at a time. Right now I have connected only one. So to select this channel, whether I am connecting my output to this channel or this channel, I have to use this button, where it is written CH1/2. CH means channel. So when it is upward, it says that I am in channel 1. When I press it, it says that I am in channel 2. But right now I have connected it to channel 1, so I will make it above, means upper part. So this is connected here. Now whatever is being generated, we have to view here. You don't worry about what the signal is being seen here. First of all, use this point called ground, GT. When you make it, it gives you a straight line. Now you have to set this straight line using this Y position movement to this center of the screen. That means here. I have set this in the center of the screen. Now I have to release the ground. Now what is this knob? What is this buttons all? This is the view of the amplitude. In the Y, you can see in the Y direction, the amplitude is changing. So suppose it is convenient for me to view this signal or is this signal, depends on the individual. If I am convenient with this size, I will use this size. If I am convenient with this size, I will use this size. So let us take that I am convenient with this size. I am using that particular magnification. And what about the x-axis? X-axis can be changed using this. But what lies in the x-axis? In the x-axis, there is the time. Time of what? Time of how many blocks this one cycle of the signal takes to complete its rotation. So if I using this X pose can move the X direction. So I am setting it in a proper place where I can say, or I can reference point be this, and I can say that this is going to be 1. From here I am saying from here it is going this way, and till here it completes one cycle. So from here I can easily count the number of blocks. As I am using the term number of blocks, you might be confused what is number of blocks. You can see this entire screen is divided into small blocks, various squares. Again you can see that each square is divided into various subdivisions. There is 1, 2, 3, 4, 5 subdivisions. Means one subdivision is of 0.2 unit. So it is 0.2, 0.4, 0.6, 0.8, 1. So in total this one block is of 1 unit in the y direction. Same thing in the x direction, it is divided into 0.2, 0.4, 0.6, 0.8, 1. So its x direction will also have the same divisions. So entire block is 1, small subunit is 0.2. So now we have to calculate the amplitude and the frequency of this signal using this CRO. So I am using, because the amplitude is always in the y direction, so I can use this xy because I am interested in only y direction. I am not interested in x direction. So when I press xy, what it does, it has suppressed the x-axis because I am only interested in my y-axis. You can see from here that it is properly coming from here to here. Now if I am saying this black line is the dark, which is having subdivision, is your reference line, using this y pose you can move this line and you can bring it over here so that you can properly count the number of divisions. Now it is here. So from here if I count, it is complete till here 1. If I say till here it is 1. From here it is 1.2, 1.4, 1.6, 1.8. It almost, it's touching 2 but not 2. So let us take it 1.9. So it is 1.9. I release the xy. So it is 1.9 blocks it is taking for this amplitude. That 1.9 into, you can see here where this knob lies in the 1. This is lies in the 1. So that 1.9 into 1 is how much? 1.9. And what will be the unit? Unit depends on where this range lies. See from this gap, you can see from this gap till this gap, there no other unit is there except some numerical values. There is only one unit called V, means volts. From this gap to this gap, there are various numerical amplifications, but there is one unit called millivolts. So whenever this knob lies in this range, the unit will be millivolt. When this knob lies in this range, the unit will be in volts. So you are getting that 1.9 is the blocks into 1, that is 1.9 is volts. So 1.9 volt. We were generating a volt of amplitude having 2 volt. Now we are getting here a signal having amplitude of 1.9 volts. So what happened to 0.1 volt? The 0.1 volt, what happened when you are transmitting this signal from this wire to this CRO, this wire has some resistance. So you know wherever there is resistance there will be voltage drop. So due to that reason of resistance of this wire, there is a voltage drop of 0.1 volt in this wire. So that's why we are getting 1.9 volt. But don't have to worry about that. This is a little error in electronic, this particular resistance of the wire. So this is how we calculate the amplitude. Next we move to how to calculate the frequency. Again make it ground, bring it to the center of the line, release the ground, and set this y-axis in such a way that you can easily count your one cycle. So if I set it here, means from this point, this is my one complete cycle till here. So what I am getting, if I can see that from this point I am completing this here, how many blocks it required? It requires 1, almost 2, or let us take it 2. So it is 1 block, 2 block. To complete one cycle it requires 2 blocks. So it is 2 into, where you can see this knob lies, see this, there is a line, this one, this lies in 0.5. So 2 into 0.5 is how much? 2 into 0.5 is 1. So 1, what will be the unit? See, from this gap till this small gap, you can see here, this small gap here and the small gap here, between this the unit will be in millisecond. From this gap to here, the unit will be in seconds. From this gap till here, the unit will be in microsecond. But right now we are in the range of millisecond. That's why 2 into 0.5 milliseconds. What we got? The time period. And we all know the relation between the frequency and the, so when frequency is equal to 1 by time period, in the range of time period you can write down whatever you got. You got how much? 2 into 0.5 milliseconds. So if I write it down in that way, 1 by 2 into 0.5 milliseconds, that is equal to 1 by 1 milliseconds. So if I want to convert, this is 1 by 1 millisecond, that is equal to again what? 1. If that is equal to 1, and if this millisecond goes up, it becomes from 10 to the power minus 3, it will become 10 to the power 3. So 1 into 10 to the power 3. So we are getting, this is 1 by second, we know is the unit of hertz. So it will become H Z. So 1 into 10 to the power 3 means 1 kilohertz, or you can say 1000 hertz. What we are giving? 1000 hertz. So we are giving from function generator 1000 hertz, and we are getting a signal of frequency 1000 hertz. You can see that we have calculated the amplitude and the frequency using a CRO, and you are familiar with various points, how to use this and how to use this, how to calculate the amplitude and how to calculate the frequency. Thank you for watching this video.